All right, the first step in this, anytime you have that you want to write the equation of a line, think in terms of y equals mx plus b. So you need to know a set of coordinates, x and y, which we have, right? Here's x and here's y. And then you also need to know the slope. Well, we want the slope of the line perpendicular to this given line. So what is the slope of this given pink line? It's negative 5/3. What's the relationship between lines that are parallel? Their slopes are? No, parallel. Parallel lines have equal slopes, and perpendicular lines have slopes that are opposite and reciprocal, right? So we change the sign, so it goes from a negative to a positive, and then we flip the slope. So the 5 goes in the denominator, the 3 moves to the numerator, and that's our new slope. Okay. So once we have our slope and our set of x and y points, we can now plug these into the slope-intercept form to solve for b. There's step 1. So we're going to plug in a 2, and a 3/5. Oops. Let me go back there. Okay. So the 2 goes in for the x, and then you have a 3/5 plugged in for the y, or for the m, and you want to solve for b. So on the right side here, 3/5 times 2, just multiply across. 3 times 2 is 6/5. And then in order to combine these mentally, again, you can use your calculator, but mentally is pretty easy too. 2 is how many fifths? If we wrote 2 in terms of a fraction fifths, it'd be 10. So now when we solve for b, subtract a 6/5 from both sides. And you can do that by hand. You get 4/5. And so we get our y-intercept. We have our slope. And so now we can plug those back into the general form of the slope-intercept. Y is equal to m of 3/5 x plus our b value, which we just found to be 4/5. Now let's look at our sketch. Is this consistent with what you would think based on our sketch? Is the y-intercept about 4/5? Yeah, it's consistent with what our sketch shows. It's somewhere around 1. And then our slope of up 3/5 would give you another point. And again, you can kind of test that if you want. 1, 2, 3, 1, 2, 3, 4, 5. Is that close to where our line would be? And that's consistent too.